The most distant human-made object is NASA's Voyager 1 spacecraft, which has managed to reach interstellar space. Imagine launching a spacecraft 45 years ago and still exploring areas it was never thought to reach, well beyond its scheduled lifespan. That's the incredible reality of a bold NASA mission that is redefining space exploration. But there's something even more fascinating. This brave spacecraft is not only miles and millions of miles from its launch point, but it continues to send data back to Earth using technology older than that of a cassette player. That's not all. The spacecraft launched in 1977 just made a discovery that has shaken the scientific community and has captured the attention of the entire world. What could this amazing find in the far reaches of space be, and what does it mean for us here on Earth? There was a key moment in history when two of the most amazing space missions ever launched ushered in the era of space exploration. It was thanks to the brilliant mind of Gary Flandreau of NASA's Jet Propulsion Laboratory that an ideal route was mapped out for the probe to reach the distant planets Jupiter, Saturn, Uranus, and Neptune. With only a pencil and 21st century engineering tool, Flandreau made a startling discovery. In the late 1970s and early 1980s, the four gas giants would be aligned in a unique cosmic configuration, creating a kind of celestial necklace. With Earth, this would allow spacecraft passing close to each planet to gain speed thanks to its gravity, as if it were being pulled by an invisible rope. Thanks to these gravitational aids, a journey that would normally have taken 30 years from Earth to Neptune would be reduced to just 12 years. However, there was a catch. This alignment occurred only once every 176 years. Faced with such exceptional opportunity, NASA acted quickly, and just in 15 days apart, they launched two identical spacecrafts, Voyager 1 and Voyager 2, in the summer of 1977, with the aim of taking advantage of this cosmic alignment. Little did they know that these twin explorers would break all records in the history of space missions. More than 45 years after their launch, the Voyager 1 and Voyager 2 spacecrafts are still operational, sending back information daily from the edges of our solar system. These probes have become the farthest ships in history, having traveled far beyond what was first imagined, which is impressive when you consider that their original mission was planned to just last 4 years. However, these interstellar pioneers had plenty of surprises in store. At the start of their epic journeys, they gave us incredible close-up images of the moons of Jupiter and Saturn, revealing worlds far beyond active and dynamic than anticipated. Discoveries of active volcanoes and ice fields forever changed our understanding of these distant corners of the solar system. Voyager 2 in particular was the first spacecraft to approach Uranus in 1986 and Neptune in 1989, becoming only a probe that existed between those planets, surprising scientists with astonishing findings in previously unexplored territories. More than 14 billion kilometers from Earth, these Volkswagen's Beetle-sized probes have defied all expectations and continue to expand the boundaries of our knowledge. The Voyager's journey began with a gravity-assisted maneuver around Venus, a feat never before attempted by any spacecraft en route to Mercury, making them true pioneers. The journey to Jupiter took the spacecraft 10 times the distance Mercury is from Earth and forced them to pass through the dangerous asteroid belt, a feat previously tackled by Pioneer 10 and 11 probes. But the challenges didn't end there. With just 69 kilobytes of memory, a fraction of the capacity of a modern smartphone, the onboard computers had to rely on their own intelligence to manage the complexities of this extraordinary journey. Data collected by instruments aboard Voyager were stored on 8-track tape recorders before being transmitted to Earth via a transmitter that only used 23 watts, about the same power as a light bulb. These probes were equipped with 12-foot diameter satellite dishes to facilitate communications. They used light-speed radio to send and receive messages, but the increasing distance from Earth, an advance of 3 or 4 light seconds each day, presented major challenges. One of those challenges, for example, was signals from Voyager 2 took more than 18 hours to reach Earth. An increasing background noise from radios, televisions, and cell phones and other sources made it increasingly difficult to pick up the faintest signals from the spacecraft. Despite these obstacles, the Voyager probes have defied expectations and continue to amaze astronomers with unexpected discoveries in the interstellar void. Their journey has rewritten our understanding of the cosmos and altered our view of the unknown. Beyond our own solar system lies the enigmatic Oort cloud, a vast congregation of comet-like objects held together by the sun's gravity and stretching to the nearest star. Although the Voyagers are still moving slowly towards that distant realm, their entry into interstellar space began when they crossed the heliopause, the boundary between our solar system and interstellar space. This boundary was initially estimated to be about 50 astronomical units from Earth, and so it was decided to continue funding the mission even as the probes neared that milestone. However, crossing this boundary did not detect an immediate change in the environment, leaving scientists baffled. The passage into interstellar space was expected to be accompanied by an abrupt increase in the number of cosmic rays, high-energy particles, traveling at nearly the speed of light, ejected by supernovae and other cosmic phenomena. However, most of the high-energy rays are deflected by the magnetic shield generated by the heliosphere, which protects our solar system from most external threats. The Voyager missions team was also closely monitored any changes in the prevailing magnetic field as the spacecraft moved in an interstellar medium, an environment composed of ionized gases and influenced by nearby stars. The interstellar magnetic field was expected to be oriented differently compared to that of the heliosphere. However, the Voyager probes did not detect any significant changes in the magnetic field. It was on August 25, 2012, that Voyager 1 finally crossed the heliopause and transmitted fascinating data confirming the expected increase in plasma density, although without evidence of a change in magnetic fields. This was surprising since it had been anticipated that when moving from a region dominated by solar energy field to one influenced by other stars, there would be a noticeable variation in the direction of the magnetic field. Let me know what you think in the comments box. If you enjoyed the video, don't forget to hit the like button and subscribe to the channel.